Hello dear students, I welcome all the standard 10 students on this online classes. You know, in the previous classes already we have discussed so many question answer from the section exercise, that is up to 26 number we have discussed, and I hope all of you have understood that one properly and clearly, and I hope you all are doing the section exercise in your notebook also. You must do that one. It will be good for you and it will be very helpful for all of you also. Okay. Today we will discuss some more question answer from the section exercises, that means 27 onward. So without delaying, let's get started this one. So the question is given here that you can see a uniform plank of a seesaw is 5 meter long and is supported at its center. A boy weighing 40 kg force sits at a distance of 1.5 meter from one end of the seesaw. Where must a boy weighing 25 kg force sit on the other end of the seesaw so as to balance the boy, balance the fast boy? So, especially in this chapter, while you will be solving that word problems, you need to draw a rough diagram first. Okay? Then it will be easier for all of you to solve that one. Okay? So, let me draw that one on the screen itself so that you can see that. Okay? One uniform plank of a seesaw is 5 meter long. Total is 5 meter long. Okay, and is supported at its center. At the center, that fulcrum is present here. Okay, and a boy weighing 40 kg force sits at a distance of 1.5 meter from one end. So if we consider from the left hand side, this one here, that boy is sitting. Okay, that is 1.5 meter from one end. Okay, this is 1.5. Okay, you can see that one from one end. So what is the distance between that fulcrum, this one F, and that boy? Yes, we can take d1 is equal to 1.5 only, because the midpoint total is 5 meter long and is supported at its center also. Okay, that is at 2.5 meter that fulcrum is present. Okay, then what is the distance of that boy from the left hand side to the fulcrum? Obviously it will be 1.5 meter only, because 1.5 plus 1.5 is equal to 2.5 meter. That is the positions of the fulcrum at 2.5 meter only. Okay, so what we have to calculate here? The distance. Here the question is telling that a boy weighing 40 kg force sits at a distance of 1.5 meter from one end. Let us consider that one from the left end. Okay, where must a boy, that means obviously that another boy must be sitting in the right hand side of the fulcrum only, and that boy is having the weight 25 kg force. So here what we have to calculate? The distance between the fulcrum and the right hand part where the boy will be sitting. Okay, so you know that one W1 into W1 into D1 is equal to W2 into D2. In the previous lesson or the first lesson we have read about that one, moment of force. About the moment of force we have discussed, that is W1 into D1 is equal to W2 into D2. So here first one, that first weight is 40 into the distance D1 is equal to 1.5. Yes, then W2 is equal to 25 into D2, that D2 we need to calculate. Okay, by using that equations we can easily calculate that D2, it will come 2.4 meter. Okay, so the distance between the boy and the fulcrum is 2.4 meter, but the question is asking that, or it is given that one from the end, that is it will be 0.9 meter only, and 1.6 meter from the center, that is from the fulcrum, but 0.9 meter from the end only. Okay, I hope all of you have understood this one. The next one, number 28, Calculate the velocity ratio and mechanical advantage of a machine which overcomes a resistance. If it is given resistance, that means it is the load. You always keep it in your mind that if it is given resistance, that means that one becomes the load. So, load is it is given 800 Newton through a distance. See, that load is moving up to a distance 0.12 meter, and the effort of 160 Newton, that is E is equal to 160 Newton, acts through a distance of 0.72 meter. So, what we have to calculate? Velocity ratio and mechanical advantage. We know that velocity ratio is equal to dE divided by dl, that is distance moved by effort divided by distance moved by the load. Okay. So, here what is the distance moved by the effort? After applying the effort, how much distance it is moving? 0.72 meter only. When an effort of 160 Newton acts through a distance of 0.72 meter only. So, distance moved by the effort is equal to 0.72 meter divided by distance moved by the load. You know that one, you can see that when a resistance or the load of 800 Newton through a distance of 0.12 meter, that is distance moved by the load is equal to 0.12 meter only. So, velocity ratio is equal to 0.72 divided by 0.12 is equal to 6, it will come. Okay, simple question only. Then the mechanical advantage is equal to load divided by effort. How much is the load? That is 800 divided by effort is also given, that is 160. It will come 5 only. Okay, very simple question this one, and I hope all of you have understood this one. Okay, the number 28 we have finished, I think this one. Then number 29. Okay. An effort of 500 Newton is applied through 0.5 meter in a machine. That effort of 500 Newton is applied through 0.5 meter in a machine. That means the distance moved by that effort of 500 Newton is equal to 0.5 meter. So, E is given, effort is equal to 500 Newton, and dE, that is distance moved by effort, is equal to 0.5 meter it is given, whose efficiency is also given, that is 90%. Okay, 90% efficiently it is working, such that resistance is overcome through 0.04 meter. That means distance moved by the load is also given, but what is the load? It is not given. Okay, distance moved by the load, that is 0.04 meter it is given, but the load is not given. Then what the question is asking? Calculate the velocity ratio, then mechanical advantage and resistance overcome by the machine. Resistance means what? As I said that resistance means the load of the body. Okay. So, let us start this one. Velocity ratio is equal to, you know that one, distance moved by effort is equal to divided by distance moved by load. And what is the distance moved by effort? 0.5 divided by distance moved by load 0.04. After solving that one, we will get 12.5 is the velocity ratio. Okay, I hope all of you have understood. Then number B, mechanical advantage is equal to, you know that one, load divided by effort. But the value of load is not given here. So, we cannot use that formula, that is mechanical advantage is equal to load by effort, we cannot use. What else it is given? Efficiency is given. So, now we have to think that if efficiency is given and already we have found the velocity ratio, then is it possible to find out the mechanical advantage? Yes, obviously it is possible, because one formula is there, efficiency is equal to mechanical advantage divided by velocity ratio. Okay, efficiency is equal to mechanical advantage divided by velocity ratio. From that, two things are already given. Efficiency is 90% and the velocity ratio is already we have found, that is 12.5. So, mechanical advantage is equal to eta into velocity ratio, that is efficiency into velocity ratio. Then mechanical advantage is equal to 90% it is given. So 90 divided by 100 into velocity ratio, that is 12.5. After solving that one, we will get 11.25. Yes, so the mechanical advantage already we have found. Now the resistance overcome by the machine, that means the load overcome by the machine we need to calculate. We know that one, mechanical advantage is equal to load divided by effort. Mechanical advantage already we have found, 11.25. Yes, effort is already there, that is 500 Newton only. Then what else we have to calculate? Load we have to calculate. You know that one. From that formula, that is mechanical advantage is equal to load divided by effort. From that we will get load is equal to mechanical advantage into effort. So mechanical advantage 11.25 into 500 is equal to 5625 Newton. Okay, simple one only. I hope all of you have understood that one. Then the next question, number 30, a crowbar of length 2 meter is used as a machine to lift a box of 100 kilogram force by placing a fulcrum at a distance of 0.1 meter from the box. See, crowbar, first thing we know that one, crowbar is a class 1 lever, that means belongs to the example of class 1 lever. Yes, so obviously that fulcrum will be present in between the load and the effort. Yes, at the middle part only it will be placed, that means in between that load and the effort the fulcrum will be present. So the total length of the crowbar, it is given 2 meter. Okay, on which purpose it is used? It is used as a machine to lift a box of 100 kilogram force. Okay, by placing a fulcrum at a distance of 0.1 meter from the box or from the load also. So load is given 100 kilogram force, and from the load to the fulcrum, that one is the, what it is called, load arm only it is called, that is also given 0.1 meter. Yes, then we need to calculate the velocity ratio. Okay, we need to calculate the velocity ratio. Then you know that one, total length of the crowbar is 2 meter. Okay, and from the fulcrum to the load it is 0.1 meter. How much it was left? 1.9 meter only it was left, because 1.9 plus 0.1 is equal to total length, that is 2 meter only. Yes, so from the fulcrum it will be 0.1 meter to the load, and from the fulcrum it will be 1.9 meter towards the effort only. Yes, so velocity ratio is equal to distance moved by effort divided by distance moved by load, that is dE divided by dL is equal to 1.9 divided by 0.1 is equal to 19 only it will come. Okay, again you know that one, the principle of machine, that is load into load arm is equal to effort into effort arm. Yes, from that formula or the equations we can get the effort also. Yes, effort is equal to load into load arm divided by effort arm. Load already it is given 100 kilogram force into load arm how much, 0.1 divided by effort arm is how much, 1.9. After solving that one we will get 5.26 kilogram force. Okay, this one is also simple one only. Just from the given thing we are trying to solve the question, and it is always like that only. Okay, the number 31, a machine is driven by a 100 kilogram mass that falls 8 meter in 4 seconds. See, this one is now something different one. Okay, so a machine is driven by a 100 kilogram mass and that falls 8 meter in 4 seconds. Okay, it lifts a load of a mass 500 kilogram vertically upwards. It lifts a load of mass 500 kilogram vertically upwards. Then number A, what is the force in Newton exerted by the falling mass? You know that one, when it is falling, yes, force is equal to mass into gravity, acceleration due to gravity, that is m into g. Yes, m into g. So easily we can calculate that how much amount of force is exerted by the falling mass, that is m into g, that is 100 into the value of g we can take here as 10, that is 100 into 10 is equal to 1000 Newton it will come. The number b, work done by 100 kilogram mass falling through 8.0 meter. You know that one work done is equal to force into displacement only. Force how much we have calculated, 1000 Newton into distance, that is 8 meter only, that is 1000 into 8 is equal to 8000 joule is the work done by 100 kilogram mass, okay, falling through 8.0 meter. Okay, simple one this one also. The number C, power input to the machine. You know that one, power is equal to work divided by time. Rate of doing work is called as power. We know that, we have read about it also. So power input is equal to work divided by time. How much work? 8000 joule divided by time in the 4 second only. So 8000 divided by 4 is equal to 2000 watt. Okay. The number D, if the efficiency of the machine is 75%, what is the output power of the machine? So work done by the machine is 75% of input power. What I said, work done by machine, that is output work or output power, that is work done by machine is 75% of input power. Okay. So 75% of input power, that is 2000, if we calculate then it will come 1500 watt only. Okay, very simple questions were there. So I hope all of you have understood, and you must do that one in your notebook also. Okay, thank you.